Howdy. Let's get started on Chapter 14. We're going to talk about system hardening and baselines. And by that we mean we need to harden our system and establish a baseline where we believe it is secure so we can measure the deviations from that. Go on, my attribution. Let's start with video 1. There's going to be 4 videos in this chapter. The learning objectives are to harden the operating systems and network operating systems, implement host-level security, harden the applications, establish group policies, and secure alternative environments. What does this mean? Basically, when it says harden, we are going to secure this. We're going to secure the operating systems. We're going to secure the host, the computers. We're going to secure the applications. We're going to establish policies to protect, and we're going to secure alternative environments. SCADA is supervisory control and data acquisition, real-time environments, and the like. Let's go through our definitions. Baselining, we talk about, I marked it out here, it's basically the process of establishing a system security state. Just think of it as we're going to come up with just that, a baseline. Anti-spam, it's going to be technology used to combat unsolicited junk email or spam. Antivirus, technology employed to screen for and block the execution of viruses and other malware. Application hardening, the steps taken to harden an application to mitigate vulnerabilities and reduce an exploitable surface. The application vulnerability scanner is the technology used to scan applications for potential vulnerabilities and weaknesses. The baseline is the system or software as it is built and functioning at a specific point in time. This is an important definition. Serves as a foundation for comparison or measurement, providing the necessary visibility to control change. Okay, so baseline, this tells us where we are at time equals 0. Now, we can use this when we implement changes to check on things, or if we believe that there's anomalous behavior. Blacklisting is the term used to describe excluding items from being on a list. So the blacklist, this can be applications, IP addresses, people, usernames, anything like that. If it's blacklisted, you'll see this is a definition opposing whitelisting. So again, blacklisting, exclusion of items based on being on a list, and can be anything can be on the blacklist. Firmware update is an update process that occurs when small software is loaded into an internal non-volatile RAM. The globally unique identifier is a reference number used as an identifier of an item in a system. Just like your car, your computer, everything now has its unique identifying number. Group policy, important definition, the mechanism that allows for centralized management and configuration of computers and remote users in a Microsoft Active Directory environment. So we're going to do this based on the groups. And the group policy object stores the group policy settings on that Microsoft Active Directory environment. Hardening is the process of strengthening a host level of security by performing specific system preparations. Again, another important definition, the process of strengthening host level security by performing specific system preparations. Other words, heuristic scanning is scanning that does not rely on a virus dictionary. Instead, it looks for suspicious behavior, anything that does not fit into your normal pattern of behavior for the operating systems and applications. So it's looking for some anomalies by looking at metrics of the operating system, amount of data being exfiltrated, differences in I/O parameters, CPU usage, something that's out of the ordinary. Host vulnerability scanner is a scanner designed to run on a specific host and look for vulnerabilities and misconfigurations on that host. Hotfix is a set of updates designed to fix that specific problem. Network segmentation is where you separate the network into separate addressable segments to limit network traffic traversal to areas of limited scope. A network vulnerability scanner is the applicability of vulnerability scanning to network devices to search for vulnerabilities at the network level. Of course, your operating system is the basic software that handles the input, output, display, memory management, all the other highly detailed tasks required to support the user environment and applications. Patch is a replacement set of code designed to correct problems or vulnerabilities on existing software. Patch management is a disciplined approach to the acquisition, testing, and implementation of OS and application software. Application patches. Patch management, obviously. Pop-up blocker, you've seen this, a tool to prevent websites from adding additional or from opening additional web browser windows or tabs without specific user comment. And the process identifier is a unique identifier for a process thread in the operating system kernel. So everything going through that operating system, everything that operating system touches will have a unique ID if possible. So reference monitor is a non-bypassable element of the kernel that processes and enforces all security interactions. It's something that it's not by discretion. It processes and enforces all security interactions, including what's being accessed, subject-object accesses, who's accessing and what's being accessed. Run levels are in Unix and Linux systems. This isn't really important unless you're interested in those, but they indicate the type of state the system is in, from halted to rebooting, maintenance levels. Security kernel is a non-bypassable element of the kernel that processes and enforces all security interactions, including subject-object accesses. Your service pack is a large collection of files, corrections, and enhancements for an operating system, application, or group of applications. So you run your security pack, your service pack, and it's going to run a bunch of fixes, corrections, updates, whatever, and you identify the security pack again by a unique identifier number so you know that it's been run. The shadow file is a file that stores the encrypted password in a system. TCP wrappers are a host-based networking system. It's in Unix. We're not going to worry about it. In some Unix systems, it filters network access. It's basically a host-based networking access control list. Think of it that way. Trusted operating system is an OS that can provide appropriate levels of security and has mechanisms to provide assurance of security functions. The trusted platform is a hardware chip to enable trusted computing platform operations. And whitelisting, an important definition, is a listing of items to be allowed by specific inclusion, the opposite of blacklisting. Whitelisting and blacklisting is pervasive through security. It deals with everything. So just remember that blacklisting is exclusion, whitelisting. So if something's excluded, everything else will be allowed in on a blacklist. On a whitelist, only those things that are listed will be allowed in. So we're going to talk about securing and preparing a system for the production environment. Many times since you're in college courses, you do work and you don't realize that in a true enterprise environment, you have a series of steps you have to go through before some system becomes operational, because the consequences could be so bad. So the process of securing and preparing a system for the production environment is called hardening. And we harden systems, servers, workstation networks, applications, everything within that system. We harden. It's too bad we can't harden people to be more secure, conscious. So once you've hardened the system, you have a system baseline that you can compare changes to over the course of a system's life cycle. So the process is called baselining. The resulting product is a security baseline. Once the process has been completed, any similar systems can be configured with the same baseline to achieve the same level of security and protection. And uniform baselines are critical in large-scale operations. Most of you probably are familiar with the Microsoft family. Windows 7, 8, now 10. The vast majority of homes and businesses run some version of Microsoft. I know some of you are Apple users. Mac OS, Solaria, so whatever that is. But what's common on these is the operating system does the same thing no matter what it's called. It's a basic software that handles input, output, display, memory management, all the highly detailed tasks, makes it transparent to you. And they have common functionality no matter what operating system you're using. So the operating system itself is the baseline of system security. And it does this through the use of a security kernel. And it's sometimes called a reference monitor, and it's a component of the operating system that enforces the security policies of the operating system. So what are the security policies? It's going to control access. It's going to control, think of it mostly as controlling access. But the important thing to know about it is security kernels must exhibit some properties that can be relied on. We need to know our security kernel's intact. So they may offer something complete mediation, or something must be tamper-proofed, it must be verifiable. Because a security kernel is part of the operating system and is a piece of software, it's highly important and critical, as you can see, to ensure that the security kernels themselves are tamper-proof and verifiable and a legitimate concern. And to do this in a technical manner, it's rooted in the actual construction of the operating system and technically beyond the level of this book. So if you're interested in OS security, this isn't the course for it. I'm just giving you kind of a peek of what it is. It talks about rings. I'm not going to hold you to this. Again, this is probably more detail than you need to know. It acts directly with the physical hardware and memory. Excuse me. Each operating system has security configurations that differ from other systems, and different versions of the operating system may in fact have variations between them. Years ago, when I was in Austin, we used to take two identical laptops and install our software. Everything, they'd been bought the same, we thought configured the same, and we would always find a difference between the two because of a change management issue or some kind of configuration. So most environments, there's a whole bunch of different operating environments in a complex enterprise type system, and they have different versions of these operating systems and different types of installed applications. You might think, well, why doesn't everybody run the same operating system? Well, in some cases, some of the systems still use and rely on older operating systems. You still see, believe it or not, in the oil and gas industry, a lot of Windows XP and the like, and they don't want to upgrade because if they have this paradigm, if it's not broken, don't fix it. They're not sure if they upgraded the operating systems, what effect it would have on other systems. So they will choose to run older operating systems. Years ago, when Microsoft upgraded the system, they actually, I can't remember which Windows version it was, but Citibank and others paid for them to maintain a specific older version for that particular business because they did not want to go through the cost of upgrading all of their financial institutions. This is not uncommon in the real world. In an ideal world, this would not happen, but in a real world, different operating systems, different versions, different types of installed applications, running different configurations at everything, and the reasons are real world. You got to stay operational. So today, because of that, we look at host-based security as being important, and specifically for the mobile device operating systems, since they interface. At one time, we called our network static. Networks were configured. If you wanted to add a computer, you had a system administrator who came in and added the computer. And now networks are very dynamic and they're changed. So it's important that, since you can't get commonality throughout the system itself, is to make the devices as hardened as possible, so that if something slips through, it still has some level of protection. So this whole idea of notion that the computer is locked down to the same degree as other system is overwhelming and often results in an unsuccessful and frustrating effort because it's a large amount of work. So we talk about host security, but it can't stop there. Host security is a complementary process to be combined with network security. We talked about this in the last chapter, the difference between the two. It would seem like network security would be the most efficient, but we can't overlook host computers because they have vulnerabilities embodied within them. So think of them as just different layers of protection that hopefully will stop any intruders at some level or another. Now, machine hardening is keeping all services and users off the system, improves the system throughout and increases securities. So when I say all other services and users, I should be more specific. We want to only allow access to those systems and users that have access to that system and keep others off. And this is use of hash values to detect changes. To do this was actually first developed at my alma mater, Purdue, by Gene Kim and Eugene Spafford back in the 90s. And it became the product Tripwire, which is now available in commercial and open source forms. So the same basic concept is used by many security packages to detect file level changes. The primary method of controlling the security impact of a system on a network is to reduce available attack surface area. So you turn off services that you don't need or that are not permitted by policy. You remove methods of connecting additional devices to a workstation to move data, such as optical drivers or USB ports. In many military installations now, they have put Gorilla Glue. You have to do this, have to have a knowledgeable person to do this, or you'll ruin your computer, to make 100% sure no one uses in a USB port. So when I said earlier, it's all about access control. That's controlling the movement of data in and out of the device. So user level controls such as limiting email attachment options or screening all attachments at an email server level, and reducing network shares to needed, it can be used to limit the excess connectivity that can impact security. So this is what machine hardening is. It's a key management issue to a secure server. And it basically, by reducing the attack surface area, means get everything out of there you don't need. Get the systems out of there you don't need. Get the users out of there you don't need. Get the devices out there you don't need. And the recording of hash values on its critical files will provide valuable information later to determine if, in fact, they have been compromised. So at that level, we also do operating system security and settings, and operating systems are hard. They're complex. They're designed to run a platform for a variety of services. They're very efficient for the users. Some services are extensions of the operating system, while others are standalone applications that use an API or something to interface with the OS. But the operating system itself must manage the security aspects of the hardware, and determining these correct settings and implement them correctly is an important step in securing a host system. That's why you have a sysadmin that's going through and looking at this. And that's why you should have your security functions and your operational functions by different people, because they may have different missions and goals. The security person is going to be looking at the risk and the vulnerabilities and how to mitigate those risks. So there's several key requirements for system hardening. The base installation of all OS and application software comes from a trusted source and is verified as correct, okay, by using hash values. So I hope you see what this means. This means we put the OS in or we put software in, but we want to be sure it's what we think it is and comes from a trusted source. So the hash values, if you remember, are to check for integrity. So that checks for the integrity of what we are installing is what we are expecting. And machines are connected only to a completely trusted network during the installation, hardening, and update processes. The base installation includes all current service packs and updates, and the current backup of images are taken after hardening and updates to facilitate system restoration to a known state. So you have your system compromised, you bring your system down, you take it back to a known secure state. So the Microsoft operating systems, I'm not going to care about this. I'm leaving these slides in here if you're interested in them. You don't need to know the specifics other than these are, they set up user account controls and firewalls and BitLockers and all this other stuff. And the same for the Unix or Linux system. This is an FYI slide. Ditto, all the Unix slides. I'm leaving them in there because I've had some people say they are interested in this and they want to be able to read this and everything. You will not be tested on this, but I have the slides in here. Hopefully I'm not going through them too fast. Let's see. That's going to end video 1. We're going to go on to video 2 in just a few minutes. Thank you.